Hi guys, so this is the first video that I'm recording, which is based on Fourier series. The first section of the Fourier series, so we'll be finding the Fourier integrals. So the question says now find the Fourier, find the integrals, or let's say find the following integrals. Find the following integrals. So this is the question that we have, and the first one, we are given the integral from 0 to pi over cosine of nx dx. So first things first, we have to integrate cosine. You know, the integral of cosine is actually a sine of nx and then divided by n, which is the derivative of the inner function, and is evaluated from 0 to pi. And then now we're just going to substitute to say now sine of n pi, and then all over n minus the lower limit sine of n multiplied by 0 in place of x divided by n. So that will give us sine of n pi, and of course divide by n minus 0. Sine n times 0 is 0, and sine of 0 is 0. That means we'll have sine of n pi and then divide by n. And so now what we do is that we substitute numbers there. Can say sine of 1 pi, can say sine of 2 pi. Any number that we substitute there is equal to 0. So that means our integral will end up being a 0. So that is our final answer. So number B, find the integral of the following. So the second question that we have is the integral from 0 to pi of sine of n pi, sine of nx, and then dx. So now integrating that, we'll get cosine, that's negative cosine of nx, and then divided by n, that is evaluated from 0 to pi. So after integrating that, we substitute our limits, that's negative cosine. In place of x, we put pi, the upper limit, divide by n minus negative cosine, and then we have n multiplied by 0 and then divide by n. So that's going to give us a negative cosine of n pi divide by n. Negative and negative we get plus, and then cosine of 0 is 1 divided by n. So what we do now, say equal, we take out minus 1 over n as a common factor, and we'll be left with cosine of n pi, and then plus minus 1 because we took a negative 1 over n. So after that, we'll say now we have negative 1 over n, and then this, we're substituting values there in place of n again, 1, 2, 3, 4, and we notice what we get. So when you substitute, we'll notice that we get a value of negative 2 when we substitute n is equal to odd. So any odd number that you substitute there will give you a value of 2, of negative 2, and then we get 0 when we substitute even numbers. So how can you say this? Is that you can actually you have cosine of n pi minus 1, so you have cosine of n pi minus 1. So when we put 0 there, we get cosine of n, we get cosine of 1. When we put 1 times pi, and then minus 1, and that should give us a value of negative 2. Let me confirm that. So that gives us a value of negative 2. So when you put cosine of 2 pi minus 1, you will get 0. When you put cosine of 3 pi minus 1, you get negative 2. when you put cosine of 4 pi minus 1, you get a you get 0. So notice that when we're putting the odd numbers there, 1, we get -2. When we put 2, we get 0, which is an even number. When we put 3, which is an odd number, -2, and so on. So that is how you can find those values there. So yes, that's it. So that hence now we end up having this. So we can say now -1/n multiplied by -2, we get 2/n and 0 here, and when n is equal to odd, and then when n is equal to even. So that's our final answer, that's our integral there. So number 3, we have the integral from -1 to 0, and our function is sine of n pi t multiplied by dt. So now we have integrating that, we get negative cosine of n pi t, and then divided by n pi, which is the derivative of the inner function from -1 to 0. And then when we're substituting our limits there, we're gonna get negative cosine. Of course, that's gonna be 0 divided by n pi, and then minus minus becomes plus cosine of now n pi, because we're substituting -1 in place of t, so all over n pi. So the negative sign will just disappear, like when you have a cosine of -30, we should give you the same answer as cosine of 30, so we don't mind the sign there. So after that, now we can actually, we see that the cosine of 0 is actually 1. So we have -1/n pi, and then plus cosine of n pi divided by n pi, and then so we can take out -1/n pi, and then we'll be left with 1 minus cosine of n pi, and then that's what we are left with. So now we can say this is equal to -1/n pi. Again, we substitute values there. So we'll notice that we get 2 whenever n is equal to an even number, and we get 0 whenever n is equal to an odd number. So that's what we have. So again, you just do the same process there, substitute the values from 1 to maybe 4, and then you will notice the trend there. So now from here you can put it as -2/n pi when n is equal to even, and then 0 when n is equal to odd. So we evaluated the integral there. That is our final answer. So the next problem that we have number 4, integral from 0 to pi over 2, and then we have cosine of nx, and then dx. And then now after that we integrate. Integral of cosine is positive sine of nx all over n from 0 to pi over 2. So substituting our limits there, we get sine of n pi over 2 in place of x divided by n, minus, when we substitute 0, we're just gonna get 0 because sine of 0 is 0, and then we get 1 over n now into sine of n multiplied by pi over 2. So notice that now when we substitute values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, when we're substituting any value here, we're gonna have 1 over n. Now the values that we're gonna get, it's 1, it is 0, and we get a -1. And then this happens when so if we substitute there, if we substitute sine of n pi over 2, we substitute 1. If we substitute 1 here to say sine of 1 times pi over 2, we're gonna get a 1. So that means there we're gonna get 1. And then if we substitute sine of 2 multiplied by pi over 2, which is an even number, we're getting what? We're getting 0. So that's the 0 that we get there. So in the middle. And then if we substitute sine of 3 multiplied by pi over 2, we get -1. So that's the -1 we get when n is equal to 3. So if we go back again, we substituted 1, 2, 3. When we substitute 4, we'll get 0 again. So notice that when we get 4, when substitute 4, we get 0. When we're substituting 6, we get 0. When substituting 8, we get 0. When we're substituting 10, we get 0. That means when n is even number, we get 0, and when it is odd number, they alternate from -1 to 1. The values that we'll get will alternate from -1 to 1. So that's what happens. So that is why now when you substitute even number of 1, you get when you're substituting even number of 1, you get 1. And then when you're substituting even number of 3, you get -1. And then when you're substituting even number of 5, again you get 1. So they alternate 5. And then you can see now that from 5 we're going to 7, so this will be 7. From 7 we're going to 9. From 9 we're going to 11. So the even numbers will alternate between those. So that is how we can evaluate our integral here. So the next problem, number 5, we having the integral from -pi to 0, and we have 2x and then cosine of nx dx. So what we're going to do here is that now we can see that we have two functions that are multiplying each other. We can use the integration by parts to say now the integral of v du should be uv minus integral of v du. So now you can let our u be equal to 2x and then our v be equal to cosine of nx. So now our du will be equal to 2 dx, and then so now this should be dv and then dx. So integrating that, we get our v, which is gonna be sine of nx all over n divided by the integral of the inner function. So substituting back there, we substitute our u, which is equal to 2x multiplied by v, which is sine of x divided by n, minus integral of v, which is sine of nx divided by n multiplied by du, and we can see our du there is 2 dx. So we're gonna get 2x sine of nx. It's gonna be 2x sine of nx, and then divided by n minus integral. So now we're gonna say integral of 2 over n multiply by, so integrating the sign there, gonna get negative cosine of nx and then divide by n. And then this is evaluated from -pi to 0, and then this is 2x sine of nx and then divided by n plus 2 cosine of nx divided by n squared from -pi to 0. So remember, when you substitute these limits, our calculator should be in radian format. So because our angles are in radians, and then after that, now what we do is that we substitute our limits, and then when we substitute the higher limit there, sine of 0 there, we'll get what? 0 plus cosine now of cosine of 0, we'll get 1 as usually. So that means we're gonna have 2 divided by n squared, and then minus we're substituting our lower limit again. Remember now that sine of according to the first problem, we found that sine, when we have sine pi over sine pi times n, we get 0. That means here the first term here will give us 0. That's gonna be 0 plus, and now we prove that I said we have n multiplied by pi. So any number that you substitute, even if you can say n sine 1 multiplied by pi, that's going to give 0, and then if you say sine 2 times pi, that's going to be 0, etc. So that means now, due to that, that term will be 0 even if we substitute a negative pi. So now when you substitute negative pi on cosine, you're gonna get 2 cosine of pi n, and then divide by n squared. So end up having what? 2 over n squared minus 2 cosine of pi n, and then that is divided by n squared. So now if we take a common factor, which is 2 over n squared, we'll be left with 1 minus cosine pi n, minus cosine pi n. So that is what we are left with. So what do we do? So we can substitute again our numbers here to see what we get. So notice that we have 2 over n squared, and then when we substitute, we get 2 when we substitute odd numbers. N is equal to odd numbers, and we'll be getting a value of 0 when we're substituting even numbers. So when you're substituting 1, you'll get 2. When you're substituting 2, you'll get 0. Substituting 3, 2 again. Substituting 4, 0. So even is 0, odd, we get a 2. So that means now from there you can put our final answer as 4 over n squared, and then that is 0, and then this is when n is equal to odd number, and when n is equal to an even number. So that is how we can evaluate our integral there. So our last problem now, we are having the integral of negative pi to pi, and then we have x squared, and then sine of nx, and then dx. So now since we're having that kind, we have an x squared here, we can actually use Kronecker's rule. So when we're using Kronecker's rule, we're just gonna say now the integral of v du should be equal to, now what we get, we will get u multiplied by v1 minus u v2, u prime v2, and then again plus u prime v3. So you'll notice that the signs there alternate, is plus minus plus minus, and then also have u v1, u prime v2, u prime v3, and etc. So if you have the fourth term, would say u prime and then v4. So now if we are taking our u to be equal to x squared, that means now our u prime should be 2x, and our u prime should be 2. So there's no need to go to u prime because it will be 0. And then we're taking our v to be equal to sine of nx, and then we're taking now our v1, integrating that, we get negative cosine of nx, and then divide by n, and then v2 should be equal to integral of v1, which is negative sine of nx, and then divided by n squared, and then v3, which is the integral of v2, we get cosine of nx, and then divided by n raised to 3. So after that, what we do is that we take these values and substitute back to our equation. Substitute back to our equation there. So that means now from this equation now we're gonna get in place of u, we're substituting, that's gonna be negative x squared and then cosine of nx and then divided by n, and then we say plus 2x and then sine of nx divided by n squared, and then we say plus 2 and then cosine, let me just write down here, plus 2 and then of cosine of nx divided by n raised to 3, and then that's evaluated from negative pi to pi. So let me just use a new page. So what we have now is that we're going to have, when we're substituting there now into our equation, when we are substituting for the first term, when we substitute negative pi, this is what we're gonna get now. We're gonna get negative pi squared and then cosine of nx all over n, plus, now when we're substituting in the middle term, of course, to make things simple, we can see that we have sine of pi n there, sine of pi n, and then we know that sine of pi n always gives us a 0, so the second term will just be 0. Go to the third term now. When substituting pi, we get 2 cosine of pi n, so that's going to be 2 cosine of n pi and then divided by n raised to 3, and then minus, now substituting the lower limit, that means we're substituting the value of negative pi. Now we're gonna get negative pi squared. Pi squared, remember, substituting to this term again, negative pi squared will be positive pi squared because the negative sign is outside. That means we'll still get negative pi squared and then cosine of n pi and then divided by n, and then we say plus, the second term again is sine, it will give us a 0, this one. So we go to the third term, we substitute negative pi here. So when we're substituting negative pi, obviously we will get 2 cosine of n pi and then divided by n raised to 3. So that is what we have. So we can just simplify the expression now. Gonna get negative pi squared cosine of n pi and then divided by n, say plus 2 cosine of n pi divided by n raised to 3, minus minus here, this minus and that minus, they will give us a positive, they will give us a plus pi squared cosine of n pi divided by 2 and then minus 2 cosine of n pi and then divided by n raised to 3. So you can notice now that this will actually cancel that and that will cancel that, and then we get a final answer of 0. So that is how we can evaluate that.